I think it's because of the comma. Okay, so let's now plot our confusion matrix, and then we'll. Okay. So as you could see that this confusion matrix has turned to us like true negatives, a false positive, which we call them the FP, false negatives, the FN, and the true positive. I'm gonna explain each of them. So on the 25 value, so these we call them the true negatives, the TN, okay? How we can describe that is that we can say that there were 25 instances of the negative classes, okay, where it's equal to 0, it were correctly predicted as negative. So these were correctly predicted as there's no heart disease, okay? These we call them the true negatives, where the patient has no heart disease, and the machine learning model that we have built, it has predicted that patient has no heart disease correctly, a value of 25, okay? So as we say, 25 instances of the negative classes were correctly predicted as negative. Here, next to it, or let's talk, on the and the false negative. So these are the true negatives, okay, and these are the false negative, which we call it Fn. So three cases or three instances of the positive classes, okay, were incorrectly predicted as negative, okay? These we call them the false negatives. Next, we have the false positives, which is the FP. This means that 4 instances or 4 cases of the negative class here were incorrectly predicted as positive. So think as you have around almost 29 cases here. Here you have 32 cases. So in 25, it represents, as we said, the true negative, where the machine were able to predict it correctly when a patient has no heart disease, okay? And 4, it's equal to the false positive, where the negative class were incorrectly predicted as positive, as you could see here. As we mentioned that the false negative, which represent the positive class, were incorrectly predicted as negative. So 29. These are the true positives. 29 cases are the instances of the positive classes were correctly predicted as positive. So the machine learning model, the logistic regression model that we've chose and we tuned, it was able to predict 29 cases correctly where the patient have a heart disease. Hopefully that's clear. It might be some, some hard to understand. However, focus on these value out of the total percentages of how is the proportion of the number of the cases where the machine learning model were able to predict correctly out of the uh, number of cases that the machine learning weren't able to predict correctly. So these are bad and these are good, our case, which has good accuracy and precision and recall. We'll explain that on next on the classification report. So now let's talk about the 9.3, which is the classification report, which summarize all of the accuracy, recall, F1-Score, and the precision score. So we said here, let's print that. Just to remind you about, all of these values for the confusion matrix, for the ROC score, and now we are gonna talk about the classification report. So let's say that our classification report will maintain or will have the main metrics, including the accuracy, precision, recall, F1 score, and support, and that is gonna be based on the data split set. If you recall that our data, we have split it into 80 and 20%. So 80% goes to the training data and 20% goes to the testing data. So whatever results that we will get in the classification report, we will get it for the data based on the two splits, which is the training 80% and testing is equal to 20%. Later on, we are gonna also show or see how we can, get the cross folds or the cross validation scores. How when we have splitted our data set into 5 folds, then it evaluates all of the accuracy, precision, recall, F1 score in each of these sets, and it returns back to us to the mean. So now we are still talking about the two splits, okay? So the classification report is a function from Scikit-learn that provide a detailed summary of the performance of the classification model. It includes several important metrics, as we mentioned, the accuracy, precision, recall, F1 score. So to do that, let's just print the classification. Simple as that. We just can call it as print, and then it has it on the Scikit-learn classification report. We'll use now our Y test dataset compared to the Y print. Y print. Let's run that. Okay. So our accuracy was around 89% for the logistic regression that we have done on the Y preds. Okay. Let's now again recall what are these metrics means. So precision is a ratio of the true positive prediction. Okay, again, it's the ratio of true positive prediction compared to the total predicted positive. It answers simply of all of the instances predicted as positive, how many were actually positive, okay? In our case, we have around 88% here, 29 out of the total is equal to 88% were able to predict with a higher precision score when predicting the no heart disease cases. Okay, recall. Next, we have recall. Recall, also some people call it as sensitivity, which is the ratio of true positive. The ratio of true positive predictions to the total actual positive. And it answers the question whether of all of the actual positive instances, how many did we correctly predict, okay? In our case, we have around 91 for the positive cases, and the negative cases has around 86%. Next, we have the F-score. The F-score is the mean or the harmonic mean of the precision and recall. So combine both of these, then it gives you the result here. And here you have the support, which represent the number of cases that were, let's say, able to, the number of actual occurrences of the classes in the specified, data set. So this is our total test data set that we separated with 20%. It's equal to 61. So these are the predictions that were made. Again, to go back to the F1 score, F1 score, as we said, it's the harmonic mean of the precision and recall. It provides a balance between the two, especially useful when the class distribution is imbalanced, okay? Okay, the accuracy, we have here the accuracy around 89%. So the accuracy is the overall or the overall correctness of the model calculated as the number of correct prediction, okay, divided by the total number of predictions, okay? So this is our, we were talking about the accuracy for each of the model when we were doing also the, the model tuning. So this is the main measure that we were using. But as you recall that we have some target as the business has asked to achieve a certain number on recall and precision and accuracy. So we have around 89%. 89% means that the model is correctly classifying, more than 89% of the all of the instances. Okay, that's something good. So how we can summarize this? So the model performs well with a high precision and recall, and F1 score, indicating that it's effective in identifying positive cases with good recall. Okay, as you could see that here it has around 91%. Okay, with good recall while minimizing the false positives here with a good precision score. Okay, as we said, the accuracy is 89% is solid, suggesting that the overall model is making correct prediction in majority of the cases. Let's compare our goals again with the, okay, we have to achieve at least 85% as accuracy, okay, 80% or higher on precision, minimize the false positives. So we have 85 accuracy, 80% of precision, 90% of recall, and F1 score has to be above 85%. Let's go down now and see our model, how it's compared to the goals of the business. I believe that we met these goals and even we exceeded the expectation. So yeah, so the accuracy, our main baseline or our our target to achieve around 85%, we achieved 89%. Precision, we were supposed to achieve around 80%, we done around 88%. Also, when it comes to recall, we were supposed to do 90, we done 91. F1 score has to cross the the 80%. We are done around 85 or more than that even. Yeah, we were supposed to do more than 85, and I think we have around 88%. So that is all for our classification report. Next, we are gonna talk about how we are gonna calculate the classification report, same report, but this time we are gonna use the cross-validation. If you recall the cross-validation where we have 5 splits of the data. So this one is into 2 main folds or 2 main data sets: training data set with 80% and testing data set with 20%. So next we are gonna talk about how we can calculate the same for the 5 data splits, which using the cross-validation function.